welcome to the channel. I'm Sachin Singh, and today we will learn how to construct a, a finite automata equivalent from regular expression. Right. So the question will most probably look like this, with the numbers or the input states present as 0, 1, or A, B, C, or something like P, Q, R. But it usually happens like it's zeros or ones or A and B used most of the time. So there are different steps to solve it. The first one is make a graph. So once you get this kind of equation, what you need to do is you'll first be required to make a graph, then convert it into a table, and this will be an NDFA, and then you'll make the corresponding DFA, and finally you'll make it back into a diagram or a graph. So we'll be starting with this, making a graph, converting it into a table or an NDFA, then making it to a DFA, and then finally a graph again. So this method actually, or these steps actually, like go down a level of difficulty. So this is descending level of difficulty, or as like I would like to put it in these words, that the chance of making a mistake is the most here. So don't want to make a mistake right in the first step, because then it goes totally wrong. So if you just get this part right, the rest part is as easy as it gets. So we'll be starting with a question that we have on a screen, which is 0 1 plus 1 whole closure, 0 0 plus 1 1 0 plus 1 whole closure. So there are, you can see there are three kinds of operations that we'll be dealing with. One is the plus sign, right? Let's just write it. Okay, let's just write this plus sign, also known as union. Okay, and I think we shouldn't be using the arrow sign, because the arrow sign will be used in different places. Okay, as and the other sign used here is star sign or an asterisk sign, which is the closure sign, right? And the third one is a sign which is actually present. It is an invisible sign which is actually present between two numbers without any sign present between them. So it's called concatenation. Now, people tend to make mistakes. You mistaking this for concatenation, because this is usually simple used in Java for concatenation, but this is not the case here. So we'll be refraining from that. Let's start. So what you need to do is, when you encounter a union sign, what you're going to do is separate these by using an arrow, like two arrows, or like this. So if you've got 0 plus 1, what you're going to do is you write 0 comma 1 or A comma B. All right. For closure, what you're going to do is make new states, and for the current state which you have created with two null signs, just place the whole thing inside the closure, right? And remove the closure sign, because then you have just made it. For concatenation, what you need to do is make a new state, and then just place the signs on either side of the arrows. All right, let's start doing this, and let's see how this goes. Okay, so what I've got here is 0 plus 1, uh, closure 0 0. So when you've got things distributed in brackets, the easiest way is just uh, pick up concatenation. So marking them with green. And now what we're gonna do is, let's start from the basics first. We're gonna make a Q naught, write the whole expression here, and make a QF. So this is what our initial graph will look like, and then excuse me, and then we'll go on further differentiating this thing. So what we're going to do is we're going to place q naught right here, and then we're going to have q final right here, and q final has two circles because it is also the final state. And then we're going to put since we have two lines here, as you can see, so you're going to place two states here. Now you can use different numbers in place of x and y, but I prefer using variables, since then like after completing the diagram we can just place put things like q naught, q1, q2, q3 in proper order, so it'll help in the end because it'll then make it proper structure, like we'll just see in a few minutes. So what we have here is something like this, and just use another color. 0 plus 1 closure, 0 0 plus 1 1, right, and 0 plus 1 closure, right. So now we've reached new state, right. So let's go to the next state and uh, open these closure things. So let's just highlight these are what we'll be working on, and these states. So this, since these both are similar, we can evaluate them together, but if you want you can do it alone, right. Like just okay, so this bar is not going to change. And now what we do here is create a new state, qp and a qq, okay, doesn't matter, and a qf, right. So this is our final state, and draw the arrows. Now we've drawn these states, and this will be our closure, right, on top of it. It's good. And here we enter the magical symbol called null, because we do not have anything else attached to it. So a new state is introduced which actually uh, joins both of them with null. And we know when we see null, what we're going to do is we're going to join them together. So what we do is, like, we can join this to this and retain any of the symbol we like. So as we know that like it's better to have the initial symbol as q naught, we can join with this q naught with q and qx with q naught, right, because this will join to be q naught, and then we can join this to be qx and q naught, right. And for this also what we can do is have qf prevail, and here also for qy and qf we can have qf prevailing. So what we can do is uh, either you can do this, or you can, before that, you can expand this. So I'll prefer doing this. It'll just make it easier for you to understand what is happening. And 0 plus 0 plus 1 1. So this is how this came. I'll just mark this with another color very quickly. These three states merged into one because of these null symbols. These three states merge into one because of these null symbols, and what we are missing is the very own 0 plus 1 part and the very own 0 plus 1 part. Now for union, what we can do is we could write this as q naught 0 comma 1, right, then 0 0 plus 1 1 qf 0 comma 1, or we could have done this, right. So we can do any of these things, which is use a comma or use two arrows, doesn't matter, right. So we've reached a new step, and then what we'll be doing is this. So now we've got 0 0 plus 1 1, and we see a plus sign in between. So first we'll go for disintegrating the union. Okay, we've got 0 comma 1 qf, and since it's just a union, what you need to do is this 0 0 and 1 1. Okay, and we get a 0 comma 1. This is nice, right? So now what you need to do is we have our concatenation function between these two, and then we can just use how to change the concatenation part to a normal graph. We just create a new state in between these two as we did earlier. So we'll have a QS and a QR. Okay, so QR and a QS. These are the two states. And yeah, Chetan Bhagat. We got two states. And okay, so this is what this looks like: 0 0 0 1 1 1 and 0 0, right? So finally we've got this, and everything is in variables, so we need to uh, just eliminate these. It's small part, so we can use here is Q3, Q4, QF, because we have used a bit of Q1 Q2 before. Like we could have written these Q1 Q2 and QX or something like that. So we've just used Q3 and Q4. Doesn't matter, you can use whatever you want. Free to use whatever you like, right? So these subscripts don't actually matter. So we've got 0 0 1 1 and our closure friends 0 and 1. This is good. And now what we need to do is we have created our graph. So we have completed our step 1. Completed what? Step 1 is completed. So let's go to the part where we create a non-deterministic finite automata. So let's just write the states: Q0, Q3, Q4, and QF. It's a final state, just circle it, and then finally write Q0 goes from Q0, Q3. Let's just write it very quickly. Okay, QF, QF, and the rest of it is phi. Right, so we've got this, and now as we see, we have to convert this NDFA to a DFA, and we can see why, because these states are not present here. We want them here, so we'll just be doing this. We'll be writing the initial state as Q naught. Okay, let's just elongate this line a bit. Okay, that's fine. And what have we got here for 0? It's Q naught and Q3, also Q naught and Q4. And you see here that Q3 is holding a smaller subscript, so we'll give this precedence over Q naught Q4, Q naught Q3. And now we look for what actually happens. Q naught gives us Q naught Q3, and Q3 gives us Q4. That's nice. And here we get Q naught and Q4. So now is we see that we've got Q naught Q3 Q4 and Q naught Q4. So choose any of them. I'll choose Q naught Q4. Okay, doesn't actually matter. Q naught Q4. The whole sole purpose of making a DFA is that these states should be present right here. So let's go for Q naught Q4, and what we get is Q naught Q3 and Q naught Q4 QF. It's good. And so after this third iteration of checking through, we've got this, we've got this. We got this, we got this. What we not got is this and this. Choose any of them. We'll be choosing. Okay, so this is not Q4, I think. This is QF. Yes, and yeah. So we've got Q0, Q3, QF, Q0, Q4, QF. So Q3 is again smaller than Q4. So just uh, choose Q0, Q3, and QF. And what we get is Q0, Q3 from Q0, and QF from both of them. Q0, Q4, QF. This part should be easy, and we know what all is in present is this. Okay, so we have just finally populated the table. Just let's check it for our safety. Q0, Q3 is present. Q0, Q4 is present here. Q0, Q3, QF is present. Q0, Q4 is present. Q0, Q3 is already there. Q0, Q4, QF is there. We just take all Q0, Q4 and Q0, Q3, QF is also present. So now we have uh, our DFA present, which is our step 3, which is completed. Okay, so we missed the completion of step 2. So okay, so this is our step 2 completed. That's quite good. Now what we're gonna do is use this and make uh, make a graph, right? Before that, we need to circle the final states which are having QF, because in our initial part we had QF, or we had assumed QF to be our final state. So we're just gonna make a graph. This is what is left. So let's just make the graph. I have Q0, Q3. I have a state called Q0. Okay, so I've got Q0, Q4, QF. So is there a state remaining? Yeah, looks like. And now what we need to do is we need to circle all of these once, because this is a DFA diagram and the final states twice. Okay, let's just color the final states so that we know that, okay, it doesn't matter, we didn't color it. Okay, circle it. Just circle it. Right, so these are the final states. Now for zeros, okay, so for zeros, we just use pink arrows. Small part here. This is nice, and this part is fairly easy. Okay, so all the zeros are drawn, and let's draw the ones now. This is a 1. Okay. Okay, so this is our step 4 completed, and this is where we complete our question. So it is quite easy once you get the hang of it. And if you want some other questions, go to the description below. You'll get a file, a Google Drive file, and probably some notes with questions and the solutions. So uh, if you want some questions, that you can definitely try them out. And that's it. Thank you, and keep practicing. Yeah, and before going, I would like to quickly point out that both of the final states, as you can see here, point to the same outputs. So let's just come to the graph part, right? And you can see both of them have the same outputs for zeros and ones. So you can reduce technically one of these states and not harm the DFA. So if you want, you can just reduce one of these and just have a single state, right? That's it. Thank you and keep practicing.